Hey guys, this is Professor Janacek. I want to go over the setup of a couple of examples where we find the area between curves. Remember when you are trying to determine this area, you first need to find the points of intersection, and then you set up the integrals. And remember, we always kind of look at this as the larger value minus the smaller value as far as the curves go. When we're working in terms of x, that's the top minus the bottom curve. When you're working in terms of y, it's the right curve minus the leftmost curve. All right, so again, this is very informal. Just want to kind of quickly go how to set these up. So first off, let's find the points of intersection. On example 1 here, we've got y equal to the line y equal to x, and we have the line y equal to x squared minus 2. Notice our points of intersection are here, here, and here. So we've got 3 points of intersection. Now, if we're looking in terms of x values, I would actually have to go from this point to this point, and then from this middle one to this third one. So that would really give me 2 integrals that I would need to set up. There are 2 intervals here. To make it a little easier, I see that I could actually write this in terms of y, because if I look at the y values, those 2 points of intersection are along the same y value, and then I have this one. So I think going in terms of y is probably the better way to look at this example. So let's see. First, let's determine the points of intersection. So what are the y values where these intersect? Again, since I'm looking at this in terms of y, let me properly write this: intersection, not intercept. Okay, I'm looking in terms of y, so I do want to go ahead and take a second and rewrite these. This is x equal to y, so this is a function of x in terms of y. And this one would be x is equal to positive or negative square root of y plus 2. Also notice that I really only need this side of that parabola, so I really just need the negative side of this. So I'm really just looking at x equal to negative square root of y plus 2. All right, well that makes life a little bit easier. Now I know what we're looking for. And then I need to figure out what are the y values where this happens. Well, the first y value, I know this line is y equal to 0. Okay, so that's one of my y values. What about the other y values? So again, what is this point here? Well, again, that is where these 2 equations intersect. So I'm looking at, and you can do this either way. If you're more comfortable working with the x values, you could go back to when x is equal to x squared minus 2, and then solve that. By the way, solving that, you'll end up with an x value. Let's see, what does that give us? Quadratic equation. You end up with x is, I believe, -1, or x is positive 2. So we actually have our points here. This point is -1, 1, and this point is positive 2, 2. Notice I can find the y value simply because y is equal to x. So however you find them, whether you set up equations in y or in x, pretty straightforward, I hope. Okay, so where were we? We've got our x values, we've got our x values, and now our y values. So remember, we're going to look in terms of y. So I'll use the y values. Oh, -1, -1, positive 2, positive 2. Now, notice I don't really need this point because that's not the area that I'm looking for. I'm looking just for this little section in here. So I only need the -1 y value. So in terms of y, our first point is -1. What about the other point? Well, that's where we're going to have to set up the other one was 0. So we know we're going to be integrating from Looking at it from in terms of the y values, you always go again from the smallest y value to the largest y value. So I'm integrating from -1 to 0. The next thing we need to do is come up with the kind of larger value minus the smaller value. So again, in terms of y, the rightmost is this one. Well, that is the equation x equal to y. And the leftmost is this one, and that is the equation x equal to negative square root of y plus 2. So we end up with putting those in there. We just need the y portion, y, and then negative square root of x plus 2. And then you, oh, no, not x plus 2. Yeah, that's a y plus 2. There we go. Much better. Okay, there you go. So you've got it from there. Hopefully you can set that up, do that integration, and I don't think it's too bad. Remember, I guess I should mention, when you integrate the square root of y plus 2 dy, you might want to use a little, actually one thing I would do is write it as y plus 2 to the 1/2 dy, and then use a substitution where we let u equal to y plus 2 and go from there. I think that's the best way to do that. All right, and email me if you have questions going any further on that. Okay, let's see. Taking a look at equation 2, or example 2 here. For the second one, we've got the sine curve, y equal to sine of x, and y equal to, or that one's sine of 2x, and y equal to the sine of x. I do want to point out that this one, where the x value has been doubled, notice that that is actually going to compress it. So multiplying something to the x value compresses your graph horizontally and does not enlarge it. Notice that's it's kind of a backwards operation. So make note of which is which. Okay, so now we're going to, I think in this case, we are going to go ahead and work in terms of x's. That shouldn't be too bad. So here we've got our there are our 3 points of intersection. There's no way of getting around it, even if we went in the other direction. If we're trying to go in terms of y like we had previously, that would be a little confusing. I think you'd still have kind of 3 sections you'd need to look at. So I think in this case, just going in terms of the y's, I'm sorry, the x's, breaking it up along those 3 into those 2 sections along those 3 points, that's a great way to do it. You could probably already see a couple of our x values, but if not, to find our points of intersection, we will simply set those 2 equations equal to one another. So sine of 2x is equal to sine of x is equal to sine of 2x is how I'm writing it. I think when solving this, it's probably going to be helpful to use one of our double angle properties. Sine of 2x is the same as 2 sine x cosine x. Then we can, oh, you know what, let me do it this way. 2 sine x cosine x minus sine x is equal to 0. And then again, I've moved things to the right, but then I've turned it all around. So take your time, make sure I follow what I'm doing, watch those positives and negatives. I'm just trying to deal with the easiest positives and negatives. But again, however you want to go about solving this, I think factoring out a sine will work nicely. So sine of x is equal to 2 times cosine x minus 1. Again, however you get there, take your time with it. You know how to do algebra, so continue with that. And then, of course, set each of those equal to 0. And then again, this will give us 2x value. Actually, it's going to give us 3x values. Sine of x equal to 0. We actually have a couple of them, and that's the ones you can see here. That was hopefully the ones that are easiest to identify. So we'll get 3x values here. And so we're going to have two different intervals. We're going to go from the first x value to the second x value. And it's going to be the top minus the bottom curve. And then we'll go plus the second x value to the third x value. Again, if we look at the top minus the bottom in this first interval, so looking in this first little bit here, top minus the bottom, the top is the y equal to sine of 2x. The bottom is y equal to sine x. So we don't need the y part, just the x part, sine 2x minus sine of x. For the second bit between the second and third point, this bit here, you'll notice that those get turned around. So we have the top one is sine of x, y equal to sine of x, and the bottom one is y equal to sine of 2x. And so we fill in those blanks in reverse order. Now when you go to simplify this, again, first off, make sure you put the numbers in here. Don't leave those as x1, x2, and x3. Put the numbers that you get here, right? Put all of those in there. And then also watch those negatives. I do want to point out that when you go to integrate the sine of 2x dx, again, try using a u substitution where u is 2x. Then you end up integrating. You'll have to, I think, put a 2 in there. I think you'll end up integrating 1/2 sine 2x times 2 dx, I think is what you end up doing on that one. So take your time. Again, I'll let you continue on with that. Hopefully you're pros at that u substitution now. So anyway, there are just setups for a couple of those examples. Feel free to email me if you have questions. Enjoy!